In this tutorial, I'm going to talk to you guys about accessing memory addresses in C. Now, in the C programming language, a lot of times we're going to want to store different information, right? And there's a bunch of different ways that we can store information. We can use things like variables, we could use arrays, we could use structs. But the basic point is that whenever we're using C, we're going to want to keep track of and maintain a bunch of different pieces of information. And one of the easiest ways to do that is by creating variables. So down here, you'll notice that I have a bunch of variables. I have this integer called age, and it just has the value of 30. We have this double GPA, 3.4, and we have this character grade, and it has the value of the A character. I have a bunch of different variables in my program, and it allows me to keep track of data really easily, and I can use these to maintain, and I can even modify these different informations. Variables are great. But I want to talk to you guys a little bit about how these work in the actual physical memory of our computer. So whenever I create a variable, for example, when I create a variable called age and I give it a value of 30, this value 30 actually gets stored on our computer. So all computers have memory. So a lot of times you'll hear people refer to this as RAM. It's called random access memory. And basically RAM is the memory that your computer is going to use when it's running programs. So for example, if I was to run this C program, my computer would use RAM, it would use that memory in order to store and keep track of all this different information. Right, so when I create a variable like int age, C is actually going to store this value 30 at a specific memory location. So it's going to take that value 30 and it's going to store it somewhere in RAM, right? When I create this double called GPA, C is going to take this value 3.4 and it's going to store it inside of the physical memory on our computer. When I create this grade, C is going to store this character and the physical memory in our computer. Now, here's the thing. When I create these variables, I give them descriptive names, right? So I gave this a descriptive name, age, so I know what's stored inside of it, right? And when I want to access this value, I can just refer to the name, right? I can just refer to age. I could modify it. I could print it out. I could do something else to it, right? I can do whatever I want with it. And the way that I can access this variable, in other words, the way that I can access the value 30 is just by referring to the name of the variable. Same goes down here. If I wanted to access the grade, right? If I wanted to access this capital A, I could just refer to the name of the variable. But again, here's the thing. All of this information is stored in our physical memory somewhere. And so whenever C needs to access that information, whenever our computer needs to access this value 30 or this value 3.4, it's actually going to refer to a specific memory address, right? So when I want to access this variable age, I can just type out age and then I can use this variable. But when C wants to refer to this value, it's not actually using age, it's going to use the memory address where this value is stored inside of our physical memory. So all of these values are stored inside of a physical address in our memory. So all of these values have an address where they're stored in memory. And when C needs to access them, it can use that address. So I'm going to show you guys how we can access that address, how we can print out the address onto the screen. And basically just wanted to give you guys an introduction into what memory addresses were. So down here, I'm going to say printf, and I'm going to show you guys how I can actually print out the physical memory address where each one of these values is stored on our computer. So down here, if I want to print out a memory address, I need to use a % and a P. So normally if I was just going to print out like a number, I could say like %D or I could say %C for a character. When we want to print out a physical memory address, we're going to say %P. And this actually stands for pointer. And we're not going to talk about pointers in this tutorial. We're just going to talk about memory addresses. But just know that you need to say %P. And now I'm going to type out the name of the variable whose memory I want to access. So I'm going to access the memory address of age. And before the variable, I'm just going to say ampersand. So I'm going to make an ampersand age, and I'm going to say %P. And now we should be able to print out the memory address where the variable age is stored. In other words, we can print out the memory address where this value 30 is stored. So let's go ahead and run our program. And you'll see over here, we're getting this number. So I'm getting this number 0060FF00. So this would be like a hexadecimal number. I guess it's not technically a number. It's like, I think it's hexadecimals. But basically, this is the physical memory address where the value of 30 is stored. In other words, it's the place where C stored the value inside of this age variable. I could do the same thing for these other variables. So actually, why don't I format this a little bit? I'm going to say here age, and then I'm going to make a new line, and we're just going to say GPA. And again, I'm going to print out another one of these addresses, and we'll do one for grade, and we'll print out the address. So now I can just come over here and I can sort of modify this a little bit. So I can just say GPA and grade. And you'll notice for each of these, I'm using this ampersand before I type out the name of the variable. So now when we run our program, we should get a nice little list of all of these variables and their corresponding addresses. So you'll see over here, we have age, and it's stored at memory address 0060FFOC. GPA is stored at this memory address, and grade is stored at this memory address. So if you were to like go into our computer or go into my computer and go to memory address 0060FF0C, that's actually going to store the value of 30. It's going to store the value that's inside of that age variable. If you were to go to this memory address, you would see the value inside of GPA. If you were going to this memory address, you would see the letter, which was a capital A. So basically, all of these variables are stored at different memory addresses. When I want to access the information in the variable, I can just refer to the variable's name. So I could say age, or I could say GPA. But when C wants to access the information in the variable, it has to use these addresses. So C would use this address, C would use this address, and this address. I can just use the variable names, and that's why C is awesome, because it allows us to do stuff like that. But when C and when our computer wants to access these values, it has to use these memory addresses. And so that's why these are useful. And when we're programming in C, it can actually be pretty useful to be able to know the addresses, like the actual physical addresses of these certain variables in memory. So a lot of times in C, when we want to work with these variables, we can just refer to them by name, and we can do all sorts of stuff with them. We can access them, we can modify them. But in other circumstances, we're not just going to want to be able to access the value, we're also going to want to be able to access their physical memory address. In other words, we're going to want to be able to know like what that address is, and we can use that for a bunch of stuff. And in future tutorials, I'm going to talk about why that can be useful. But for now, I really just wanted to kind of give you guys an overview of what memory addresses are, how we're using them in our program, and how we can print them out. So again, I just use this ampersand, and then I type the name of the variable, and I use this %p to print it out. In this tutorial, I want to talk to you guys about pointers in C. Now, a pointer is basically just a type of data that we can use inside of our programs. So up until this point in the course, we've been using a bunch of different types of data, right? We've been using things like integers, and an integer is just a whole number. We've been using things like doubles, and a double is a decimal number. We've been using chars, and a char is basically just a character. And now I want to introduce you guys to another type of data, which is called a pointer. And a pointer is basically just a memory address. And a memory address basically refers to a physical address inside of the memory of our computer where we're storing a value, right? And I think pointers tend to confuse a lot of people who learn about them. And this is sort of one of those topics in C that everybody dreads because it's, traditionally very confusing to understand. But actually pointers are extremely simple. And the problem is that they just get overcomplicated. So what I want you guys to do is I just want you guys to think of a pointer as a type of data. That's all it is. It's just a type of data that we can work with in our programs. It doesn't have to be any more complicated than that, right? I can work with an integer in my program. An integer is a whole number, right? I can work with a double in my program. A double is a decimal number. I can work with a char in my program. A char is just a character. I can work with a pointer in my program. A pointer is just a memory address. That's it. A pointer is just another type of data that I can use and I can work with inside of my programs. And it just happens to be a memory address inside of the memory or the RAM in our computers. That's all it is. It's very simple. People overcomplicate pointers, and they don't have to be overcomplicated because it's just another type of data, just like an integer or a double. But instead of being like a whole number or a decimal number, it's a memory address. So hopefully that makes sense. And I hope that you guys don't try to overcomplicate this too much, because it doesn't have to be. So down here in my program, I have an integer that I've created, and it's called age. So I just said int age. And inside of this integer age, I'm storing a whole number. I'm storing an integer, right? 30. And if you've been following along with this course, in the last tutorial, we talked about memory addresses. And we talked about how all of these variables are actually storing these values at physical addresses on our computer's memory. So down here, I have this print statement, and I'm just printing out age's memory address. And I'm using this %p, and I'm just printing out ampersand age. And we talked about how this ampersand, when I put this in front of the variable, basically it's going to give me the physical address in memory where this variable, in other words, where this 30 value is stored. So if I run this program, you guys will see over here it says age's memory address, and it's this hexadecimal number, right? This is the physical memory address of the age variable. What did we just talk about before? Remember what I told you? Pointers are memory addresses. That's what they are. It's a type of data. A pointer is a type of data in our program, and it's a memory address, right? When I use this ampersand and I type out the name of a variable, this is giving me the memory address, right? I'm able to print out the memory address. So really, this is a pointer. This is a type of data in our program that is a memory address. Just like an integer is a type of data that's a whole number, and a double is a type of data that's a decimal number, and a char is a type of data that's a character, a pointer is a type of data that's a memory address. And this right here, this guy right here, is a pointer. So it's just the memory address of the age variable. That's it. And when I want to print out a pointer, I can use this %p, and it'll allow me to print it out onto the screen, and everyone's happy. So essentially what I'm doing here is I'm printing out a pointer. When I say %p, I'm telling this printf function that I want to print out a pointer, and then I give it a pointer over here. I give it a physical memory address. That's what a pointer is. Now we understand, and hopefully you understand, that a pointer is just a type of data, right? It's just a memory address. And we can access the memory addresses of specific variables by using this ampersand and then typing out the name of the variable. And that can be pretty useful. Now that we understand that, I want to show you guys how we can work with these pointers. So over here, I have an integer variable called age. And this integer variable is storing an integer value 30. I'm going to say that one more time. I have an integer variable, and this integer variable is storing an integer value 30. I could also create a double variable. So I could create a double called GPA, and inside of this double variable, I could store a double value like 3.4. I could also create a char variable called grade, and inside of this char variable, I could store a character, A. I could also create a pointer variable. And inside of that pointer variable, I could store a pointer, okay? So just like I stored a character inside of this character variable, and I stored a double inside of this double variable, I could store a pointer inside of a pointer variable. So we can actually store these pointers inside of a pointer variable. Now, here's where this is going to get a little bit tricky. When we create a pointer variable, we actually need a physical memory address, right? So when I create this integer variable, like I can just come up with a number right off the top of my head, right? I can just say like 30. When I create a double variable, I can just store whatever number I want to store. But when we create a pointer variable, remember, we're going to be storing a memory address. And I don't necessarily know any memory addresses like right off the top of my head. At least I don't know any meaningful memory addresses. So when I create a pointer variable, what I want to do is store the memory address of a variable that's already in our program. So I'm going to say that one more time. When I'm creating a pointer variable, inside of that pointer variable, I'm going to store the memory address of another variable inside of our program. So let's say that I wanted to create a pointer that would store the memory address of this variable over here. So store the memory address of age, right? I can create a pointer just like this. So I could say int, an asterisk, And now I'm going to give this a name. So I'm going to give this pointer variable a name. And remember, this pointer variable is going to store the memory address of the age variable. And generally, when you're naming a pointer, you're going to start with a lowercase p, and then you're going to type the name of the variable whose memory address you're storing in the pointer variable. So I'm going to say p age, right? Because this pointer variable is storing the physical memory address of the age variable. Now what I want to do is set this equal to the memory address of the age variable, which we can access using this ampersand. So I could say ampersand age. So now this pointer variable is storing the memory address of the age variable. I'm going to do the same thing down here for this GPA. So if I wanted to create a pointer variable that would store the memory address of the GPA variable, I could say double asterisk, and I'm just going to say p GPA, just like that. And I'm going to set this equal to the memory address of this double variable, which we can access using this ampersand and then the name of the variable like that. I'm going to do the same thing down here for this character variable. So I want to create a pointer variable, which is going to store the memory address of the character variable. So I'm just going to say char asterisk a grade, and I'm going to set this equal to ampersand grade. Okay, so that's all I'm doing, right? So now I have this integer variable, and I have this pointer variable, which is storing the memory location or the memory address of the age variable. I have this double variable, which is storing a double, and I have this pointer variable, which is storing a pointer, and the pointer just happens to be the memory address of the GPA variable. I have this char variable down here, and then I have this pointer variable, which is storing a pointer, which just happens to be the physical memory address of the grade variable in our memory, okay? And that's basically all you need to know about pointers to get started. A pointer is just a type of data. It's just a type of information that we can work with in our programs. It just happens to be memory addresses, right? An integer is a type of data that we can work with in our programs, and it just happens to be a whole number. A double is a type of data that we can work with in our programs, and it's a decimal number. A char is a type of data that we can work with in our programs, and it's a character. A pointer is a type of data that we can work with in our programs, and it's a memory address. Hopefully that makes sense. And just like we create integer variables and double variables, we can also create pointer variables. The only difference is whenever we create a pointer variable, we're going to store the memory address of another variable in our program. So you'll see over here, when I create this pointer variable, I'm using the data type of the variable whose address I'm storing. So over here, when I'm storing the address of an integer variable, I'm saying int here. When I'm storing the address of a double variable, I'm saying double here. When I'm storing the address of a char variable, I'm saying char here. And that's the basics of using pointers and also creating pointer variables and storing memory addresses inside of variables. In this tutorial, I want to talk to you guys about dereferencing pointers in C. Now, a pointer is basically just a type of data that we can work with in our programs that is a memory address. So sometimes in our programs, we're going to want to work with memory addresses. We're going to want to use them in our programs and do certain things with them. And those memory addresses are basically called pointers in our programs. And when you dereference a pointer, essentially what you're doing is you're going to the memory address of that pointer and you're grabbing the piece of information from there, right? So all pointers are memory addresses. And when we dereference a pointer, we go to that physical memory address and we get the information or we get the value that's stored inside of there. So I'm going to show you guys how we can do that in C. It's actually really easy and can be pretty useful. So down here I have this integer, and it's an integer variable and it's storing the integer value 30. And over here I have a pointer variable which is storing the memory address of 30. So it's storing the memory address of our age variable, as you can see right here. And down here I'm just printing out this pointer. So I'm printing out p age, I'm using this %p, and I'm just printing it out to the screen. So why don't we take a look and see what we get. So you'll see over here, we just get this memory address, probably exactly what you expected to get. So over here, I want to show you guys how we can dereference a pointer. So this pointer variable page is storing the memory address of this age variable, right? So when we printed it out, we basically were given the physical memory address where this number 30 was stored. So page is storing the memory address of 30. It's storing the memory address where this value is inside of our computer's memory. If I want to dereference a pointer, basically what I'm going to be doing is I'm going to be going to that actual physical memory address and grabbing that piece of information. So the way that I can dereference a pointer is by using the asterisk. So when I'm printing this pointer out, I can dereference it by using this asterisk. But now over here, since I'm dereferencing this pointer, I need to print out a number instead of a pointer. Because when I dereference the pointer, this is no longer a pointer. This is no longer a memory address. Now, this is going to be whatever was stored at the memory address the pointer was pointing to. So this is going to be an integer because this pointer variable was storing the address of an integer, right? So when I dereference it, this is actually going to be an integer. So let me show you guys. I'm going to print out, or I'm going to run our program, and it should print out 30. So you'll see there we get a 30. So basically what's happening here is we're dereferencing the page pointer variable. We're dereferencing the page pointer, which basically means we're going and grabbing the actual, physical value that's stored at the memory address that the pointer was pointing to. And that's why we get 30. And that's basically what dereferencing is. You have a pointer, you can dereference it, and you basically just get the value that it was pointing to. It's essentially all we're doing. So I want to show you guys how we could do this just normally. So for example, I have this age variable. If I just typed this out, if I wanted to get the address of this age variable, I could use this ampersand, right? That's basically what we did up here. But what I could do is I could just dereference this. So I can say ampersand age, and then I can put a asterisk here, and this is actually going to dereference that entire thing. So now when I run my program, it's going to print out 30. So it's not going to print out the memory address, it's just going to print out 30. So you can see over here we get 30. So I could actually do this like as many times as I want, and this will maybe just illustrate what's happening. So I could put an ampersand here, and now I'm going to get that memory address again. So you'll see we're getting this memory address, and I could do the same thing. So I could dereference this one more time, and you'll see now we're getting that 30 value again. So I mean, basically what I'm doing here is I'm constantly like here I'm getting the memory address where the age variable is stored. Then I'm dereferencing it and getting the value. Then I'm getting the memory address again, and then I'm dereferencing it again. So, hopefully that makes sense. When you dereference a pointer, you're basically just getting the value that that pointer is pointing to, or you're getting the value that's stored in the memory address of the pointer.